This is Team 8813, the Winter Soldiers. Today we will be showing lesson number 6. Lesson 6 talks about the different types of turns and how to program them on the robot. You must have the EV3 built before this lesson has started. We strongly encourage you to experiment with the robot yourself. Apart from what is learned from today's lesson, we will now begin this lesson. The following few slides will be reviewed in Wednesday's class. They will not be narrated. Students, now is the time to pause the video and review with the class what you learned from last week's lesson. Make sure to have your last week's homeworks done and the robot built. You may now pause the lesson. We will now begin the Lesson 6 material. Today's objective: students will learn about the different types of turns and how to program them, as well as the difference between the tank and the steering block.
There are two types of move blocks: the move steering block and the move tank block. So far we have discussed only the move steering block. In the move steering block, changing the direction will alter the intensity of the turn. The block allows you to change the angle of the turn, but you are only able to control one motor. We will not be learning to use this. Although the move tank block does not let us change the angle of the turn, it lets us change the speed of both individual motors. We will use the move tank block for turning. It will allow us to do the same thing as move steering block.
Turning. Aside from the basic programming of moving forward, turning is the second most important concept that everyone on the team must know.
There are three types of turns we can do on the EV3 robot: pivot turn, point turn, and curve turn. During a pivot turn, only one drive motor is on, so only one wheel moves while the other motor is turned off. This causes the robot to rotate in a circular motion around the stationary wheel. This is the most common turn and the easiest to program.
To do a pivot turn, we need to use the move tank block and set the power of one motor to 0 and the power of the other motor to be how fast you want the turn to be. Change the rotations or degrees value to how much you want the robot to turn.
During a point turn, the motors move in opposite directions at the same speed, causing the robot to rotate at its center point. This turn is a quick movement and requires less space.
To do a point turn, we need to set the power of one motor to a positive value and the power of the other motor to the opposite value. For example, -30 and 30. Change the rotations/degrees value to how much you want the robot to turn.
During a curve turn, both motors move simultaneously at different speeds in the same direction, which makes the robot turn in an arc, circle, or oval. This turn causes the robot to turn at a longer period of time.
To do a curve turn, we need to set the power of one motor to a higher power than the other motor. Change the rotations/degrees value to how much you want the robot to turn.
Discuss what this block will do on a robot with your teams. Press pause. After you have an answer, then press play again. This block, when run on a robot, will rotate the left wheel 60 degrees for 0.6 rotations. Discuss with your team what this block will do when run on a robot. Press pause. This robot will rotate its left wheel 60 degrees for 0.72 rotations.
Pause the video to look over the practice. This block will make motor B move for 0.72 rotations at 60% power. This will make a pivot turn to the right. Here is additional practice that we will go over the answers with in next week's class. Make sure to have all the practice done by then.